Hello there, and welcome to everyone joining us for this latest IoT Central webinar. I'm Clive Maxfield, everyone calls me Max, and I'll be your host. In addition to being a practicing engineer myself, I also act as a technology consultant, author, speaker, and educator. I'd like to start our webinar by thanking ARM for sponsoring today's event. ARM is a leading supporter of the IoT Central community, and we're very grateful to have them as sponsors. Today's webinar is the third in a four-part series entitled Fast and Fearless, the Future of IoT Software Development. Today's topic is making the most of IoT connectivity. Before we begin, I'd like to briefly review the format of today's proceedings. The event will be 1 hour long. We have 4 speakers who I'll introduce in just a moment. And this event is being recorded and will be available on iotcentral.io tomorrow. I'd also like to encourage you to provide questions throughout the presentation. I will be reviewing and presenting these questions on your behalf during the event. Now, I'm very pleased to be able to introduce today's speakers. Samuela Falconer is the Principal Product Manager at u-blox. Omer Chima is the Head of Wi-Fi Business Unit at Renesas Semiconductor. Vinka Geiserman is the co-founder and CEO at the Things Industries. And Thomas Kirkins is the System Architect at Quervero. So thank you all for joining us. And whenever you're ready, you can take it away.
Good morning and good afternoon, everyone. Thanks for joining the webinar. Today, we're going to talk about 2 new cellular standards for IoT called LTE-M and NB-IoT. Let me say, this is not really meant to be a complete tutorial for these 2 technologies where we go in depth through all the technical details and make comparisons. We don't have time for that. So today, I will highlight just the few key strengths of these technologies and discuss with you the reasons why these standards became so popular in the IoT market. And we can start off with a quick overview of the cellular standard evolution. And it all began with 2G and 3G technologies being adopted by the mobile phone industry and by extension being used in the M2M machine-to-machine market. Then standard evolved into LTE and different flavors of LTE, delivering higher and higher data rates. But in recent years, new standards emerged, now more tailored to the needs of the IoT market. That was the case of LTE Cat 1, and the trend just continued with the new technologies, LTE-M and narrowband IoT that you see here in their first versions called Cat M1 and NB1, and their subsequent versions called M2 and NB2. All of these technologies, all of them are moving in the direction of 5G. And in a sense, they are shaping the way 5G will be. All of them, LTE-M and narrowband IoT in particular, are converging the direction of 5G MMTC, that stands for Massive Machine Type Communication, that is targeting applications demanding low data rates, power efficiency, and typically low cost. It's also important to say that both technologies will be and will remain fully functional once 5G is completely rolled out. Just a few words about coverage. What you see here is an image taken from the GSMA website where you see the today deployment status around the globe for these 2 technologies. You see LTE-M and NB-IoT now widely available across several regions. And what we have seen, we've seen them replacing in many cases traditional technologies in standard applications like metering or like asset tracking. But they're also enabling new use cases, so new applications like in smart cities or like with portable healthcare systems. There's no single way of using these 2 technologies. As a rule of thumb, we can say that you may prefer LTM in case of mobile applications, while NB-IoT delivers better performance in static or semi-static applications. Now, I want to point you to three key technical aspects of LTM and NB-IoT that allowed the two technologies to become popular in the IoT ecosystem. And the first one is called EDRX, that stands for Extended Discontinuous Reception. As a concept, it's very similar to the paging concept you might be familiar with working with 2G or 3G standards. So basically, once the data exchange is completed, you can switch off the radio on the unit and enter this low power idle mode called EDRX. In this case, the unit has an assigned paging window during which it can switch on the radio just to listen for any incoming data. So at that moment, the unit becomes reachable from the backend server. And in this way, you preserve power. So it's an extension of paging that delivers energy savings that are well beyond the reach of traditional technologies. And EDRX can be set up to minutes or even hours. And there are multiple use cases that may rely on this. A good example is the portable healthcare systems. In this case, we have an object that is typically battery powered and that locally monitors the patient parameters. So you have two key needs. The first one is to minimize current consumption, power consumption, and the other one is to be immediately able to send data up to the network, to the cloud system. And in the same way, you want really the cloud to continuously monitor the device state and send encased data back. So in this case, EDRX really helps you remain connected with the network, minimizing power consumption. An extension of this is called PSM, that stands for Power Saving Mode. In this case, you release completely the connection with the network, and essentially you work entirely offline, reaching the lowest levels of power consumption. You may stay in PSM for several minutes or even for several hours. It depends on you. And the key benefit here is that whenever you have to wake up the unit from this mode, the unit does not need to perform the usual network registration that is typically time-consuming and energy-hungry. So in this case, you resync immediately with the network in a faster and energy-efficient way. A good use case is the asset tracking. In this case, typically, the device just wants to remain asleep most of the time to optimize power consumption. So you remain in power saving mode most of the time. You don't need to be reachable from the backend server. You wake up from time to time, for example, every few hours, to collect the position and send it up to the network or cloud system that typically doesn't need to send data back every time. So in this case, the asset tracker goes back into the PSM mode as soon as possible, preserving power. And finally, I want to give you this one. This is a third important technical aspect around LTEM and NB-IoT. They both deliver an enhanced coverage. If we make a comparison with traditional technologies like LTE Cat 1, you see here LTM delivers 15 additional dBs. NB-IoT shines with 23 additional dBs. So it's easy to see its application on smart meters that really exploit this extended coverage. In this case, you have a unit that has to be deployed underground or in general in challenging network conditions. So in this case, both technologies really allow you to stay connected with the network and minimize power consumption. So for which applications do we recommend LTM or NB-IoT? Well, there's no single answer to that or a single way of using these technologies. In general, you may prefer LTM on applications demanding mid to high data rates and mobility. That is the case of consumer trackers, asset trackers, connected healthcare systems. Vice versa, NB-IoT is simply better in terms of efficiency, power consumption in static applications, like smart metering. And finally, there are use cases, for example, in smart cities or in the environmental sensors, where the two technologies are kind of interchangeable. Now, talking briefly about u-blox. In u-blox, we have a variety of solutions for IoT, means for LTE-M and NB-IoT. u-blox, the important thing is that u-blox strategically decided a few years ago to invest on its own silicon chipset. And as of today, u-blox is the only IoT supplier in the market with a complete chipset and module know-how. That means all the products you see here are entirely designed in-house and based on chipset made from u-blox. So the entire product from the chipset up to the module. And by the way, they all include ARM IP inside. And this is what we believe is the best way to serve the ecosystem, the market, delivering roadmap stability, guaranteeing product longevity, and the best support possible. By the way, you may appreciate these two logos. The SAR R5 family won a CES award this year for its security implementations, while Alex also got its own award this year and received the IoT Product of the Year from IoT Evolution. So to wrap up, how to get started. Here you see a collection of things. I want to point you to the tools we make available. We have evaluation kit to get started. We have, if you prefer, application boards where you can develop your code directly in, or blueprints, so a collection of reference designs and best practices. With this, I leave you with this list of crosslinks for your reference. And I really want to thank you for your time today. And with this, I will hand over to Omar. Thanks.
Thank you, Samuel. Hi, everyone. My name is Umar Chima, and I lead the IoT Wi-Fi business at Renesas Electronics. Today, in next 10 minutes or so, I would like to go through the topic of simplifying smart home with ultra-low power Wi-Fi. Before I get into details, a very brief introduction to Renesas Wi-Fi. What we offer today, it's the lowest power Wi-Fi platform in industry that delivers a multi-year battery life for IoT applications while maintaining industry-leading range and security capabilities. So really, it's the first time in the history of Wi-Fi that a product, a Wi-Fi SoC, is enabling this kind of battery life. And I will show you in next few slides how that changes the smart home. Starting with this diagram that summarizes today's smart home architecture. Excuse me. So as you can see here, there are multiple protocols that are being used in smart homes. We have Wi-Fi being used for smart thermostats, door locks, home appliances. Zigbee and Z-Wave are being used for lighting, garage door openers, smoke alarms, and then for high-end applications such as video games, TVs, we have high-end Wi-Fi or Ethernet. All these devices, when they have to talk to each other, they send their data to a hub, and then hub in return sends this data to access point that eventually goes to the cloud. The problem with this kind of smart home implementation is that first of all, hub is adds cost complexity. It adds new points of failures in home. And secondly, it's not easy to set up for a home network for those people who are not familiar with the technology. Going a little bit more into detail for the problem with the home hub. First of all, as of today, hub makers, they control the smart home. If you talk to, let's say, hub makers, their vision is to own the smart home. It's a platform play for them, similar to, let's say, Google owning Android, companies like Wink, or other smart home hub makers. They want to own the data so that they can monetize it down the line. Hub makers, they can disable the hub if they want to, and that happened actually last year with Wink, when they suddenly changed their policy and started asking their their customers to start paying monthly fees, which resulted in quite a bit of bad publicity for them, unhappy users who actually revolted against the device. Also, sorry, some technical problem, excuse me for that. Other issues that device makers who are working with the home hub, they need to join the hub's partner ecosystem. They need to maintain the capability for the hub, and eventually, if the hub owners they will own the data, there is limited upside potential for the device makers. So this is a problem with today's some smart home based on the hub architecture. Other issues that are also relevant is the problem with the Zigbee and Z-Wave, which are protocols traditionally used for low power applications. Zigbee has a lot of fragmentation. Historically, with Zigbee 3.0, that has been solved, but still two different certifications for hardware and software. Z-Wave is a proprietary protocol owned by one company. So really, it's not a standard, so there's lack of transparency, and the radio is expensive. And this causes additional complexity in setting up smart homes. On top of that, mesh networks, unless they are managed properly, mesh sometimes causes difficulties for smart home owners who want to set up their own network. So these are some of the limitations with Zigbee and Z-Wave. So what we believe is going to happen in the future is that Wi-Fi, it will simplify the home architecture because of the evolution of ultra low power Wi-Fi and Wi-Fi 6. How? For gaming consoles or TVs or those applications where high bandwidth is a requirement, Wi-Fi 6 is emerging as a standard, and those applications will be taken away from Ethernet. On the other hand, the applications that are power sensitive, that require very long battery life, ultra low power Wi-Fi is emerging. And that way, Wi-Fi is going to become the ubiquitous smart home protocol. It solves the problem that I mentioned on the previous slides. Dependence on hub makers is no more a problem because Wi-Fi directly connects to the access point. Proprietary nature of Z-Wave protocol is not a problem because Wi-Fi is a standard universal protocol. Zigbee compatibility is not a problem. Mesh network issues might be resolved because Wi-Fi is a star topology, and also cabling issues with Ethernet can be gotten rid of because of the wireless nature of Wi-Fi. At Dialog, we, as I mentioned earlier, that we are the leaders in the low power Wi-Fi space. And this is not our claim. Actually, recently there was a benchmark released by Embassy. The benchmark is called IoT Mark Wi-Fi, which is designed to provide a comprehensive assessment of the entire platform in a real usage scenario. And our SoCs, they scored 815, which roughly translate to 815 days of battery life for an IoT sensor running on 2 AA batteries. And this is at least 50% better than the closest competitor. Also, the solutions that we are offering, they have very low BOM. We offer full integrated system on chip. So for a developer who wants to develop around, let's say, our Wi-Fi system on chip, all they need is to add some flash, antenna, 1 to 2 crystals, and some RLCs. So with minimum BOM, with minimum additional components, the Wi-Fi IoT applications can be developed using our technology. And third point that is also very important is that while we are focusing on low power Wi-Fi, we are not compromising on the range or the signal strength. We have a link budget of 119.5 dB, which is industry leading. And that is very useful in those cases where the IoT devices, they're at the edge of the network. Imagine a smart door lock, for example. In most of the cases, these door locks, they are far away from the access point. So even in those cases, because we have an impressive link budget, the quality of the signal doesn't drop with the distance. And the IoT device makers, they can develop those applications without thinking about the quality for the experience for the end users. So in summary, we are very excited about our technology. We believe that in next few years, Wi-Fi will emerge as a dominant smart home protocol. It will emerge as the de facto standard for all smart home applications, which will simplify the home network. And that way, adoption of smart home, which we have been talking about for several years now, will be accelerated. That's it from my side. Thank you very much. And now I will like to give my mic to Winke. Thank you.
Yes, hello, hi. Thanks for having me. My name is Winke Griezmann, CEO and co-founder of the Things Industries. And I'm going to tell you about what we do with regards to LoRaWAN and yeah, how we help customers all around the world to be successful with LoRaWAN networks. So LoRaWAN is a wireless frequency, radio frequency technology that allows you to send small pieces of data from small sensors to applications over a long range, or when you're in need of building that through a private network. So of course we just heard about NB-IoT and LTN as a cellular technology. LoRaWAN is more focused on building local networks that require low power devices that can send data over a long range to a private gateway, then feeds the data into the cloud. So we support customers all around the world by building all kinds of solutions, and these solutions all require a piece of radio frequency data transmission that allows small pieces of data to be sent over long distance by using very low power, so it can run on a battery. If you look at the LoRaWAN standard, it's already there for now 6 years, and there's a massive ecosystem of all kinds of different devices. So this is really just a small piece of all the partners we have with the devices. So you can think of parking sensors, you see that here in the middle, weather sensors, humidity, temperature, and even mouse traps, trackers, etc. So there's this massive device ecosystem around this radio frequency technology. So just to dive a bit into the technology and to keep it short, is it's ultra low power. So if you send a few messages a day, some devices can even last up to 10 years. Of course, at a stretch, usually it's around 3 years, but the power consumption is very, very low of transmitting these small pieces of data. Another point is this long range. So, for instance, for providing network connectivity for a campus of a building, usually you don't only need a few base stations. In LoRaWAN, we call them gateways, to cover an entire area. There's a very good deep indoor penetration. It runs in Europe on 868 megahertz and in the US on 915 megahertz. And that's typically because it's at a lower frequency, it's easier, it's better fit for penetrating buildings. It's a license-free spectrum. It's just like Wi-Fi. You don't need to ask anybody permission to set up these fairly large networks, as long as you're staying within the spectrum regulation. It includes all kinds of geolocation features as well. So you can do ranging and positioning based on different metadata on the RF layer. So this is very interesting if you, for instance, have use cases that just require to know, okay, is it on this campus? Is it in this distribution center? Is it on this airport? And sometimes that data can be very interesting, even if it's not very, very accurate. Well, what's also interesting is they can public and private networks, and they can work together. So you as a company can build your private networks, but there's also operators that build LoRaWAN networks, and they're actually compliant and interoperable through the standard. So actually, if you build a private network, you can even include coverage of public LoRaWAN networks into your application. The end-to-end security is within the protocol. So LoRaWAN is the network protocol, and within that there's two levels of encryption, one for the network and one for the application. And this creates a very interesting use case where you can easily use other companies' networks or other people's networks, yet making sure that the end-to-end encryption you implement is 100% secure. We support firmware over-the-air update for certain embedded ecosystems. There's a certification program, and there's a massive ecosystem of developers that can help you out. It's actually quite a large group of developers that you can go to help you out with your IoT solution. So this is a bit about the boring part. Now about, okay, where do we see that LoRa and LoRaWAN become successful? It's a lot of different areas. So we help, for instance, Deutsche Bahn by creating networks for all their railway stations. And one of their killer apps is that they're going to use it to synchronize the clocks on these railway stations. So that's one of the first use cases, but they're following up with all kinds of other sensors, and they can completely control the security and the network here. We see that's being used on industrial sites where movement sensors detect vibration and then report that back to operations, and based on that, planned maintenance can be done. Another customer is Wallenius Wilhelmsen. They operate these large ships. They do a lot of condition monitoring on all kinds of systems, and also here predictive maintenance is the use case. We're working with Axions on all kinds of industrial sites, measuring all kinds of activities. This is an interesting use case where we help out a company that is providing temperature humidity sensors to check if museums are actually preserving the art in a certified way. So they creating these reports on, okay, like you're putting up this art in the museum, and then these paintings and these rooms and these exposition halls, they have to be maintained at a certain humidity and a certain temperature. And this is a company that specifically focuses on this niche. Super exciting. We're working together with the security, retail security company that is using LoRaWAN to protect theft of retail companies that are selling electronics. Elderly, we're working with service providers in elderly care, placing sensors on pillboxes, doors, measuring occupancy, measuring movement, and also making sure that they can increase the quality of the service of the assisted living housing. WeWork uses our platform to create occupancy sensors for meeting rooms. Meeting rooms for a company like WeWork means overhead, like they don't make any money out of that. But if they, for instance, can see through the occupancy sensors that actually these meeting rooms are not being used that often, they can optimize their floor plan and their operations. Same for a company called Spacewell. We're helping them with their IoT networks. We're tracking both bulls with this company, and this company is tracking cows. Two different use cases. The bulls are being tracked on the level of activity, but for cows, there's a lot of additional data that's being tracked, as well as their location. So these cows are in places like New Zealand and Australia, where you have these massive farms. And we see that there are quite a amount of agricultural associations. They take this matter in their own hand, and they're building these IoT networks across the rural lands. And then there's many different use cases around soil moisture measurement, but also the controlling of water valves for irrigation. It's really interesting, inspiring to see these companies building all the kind of these innovative solutions, quality measurements, and what we also do is we'll help companies building cold chains, doing cold chain analysis for fridges of food, of all kinds of processes inside of hospitals as well. So and to finish off is that this is the famous use case where maybe LoRaWAN has also what you might have heard before, but this is a mouse trap, and when a mouse is caught, then a signal goes off, and this means that you can massively reduce the OPEX into facility management use cases, because when you have a smart mouse trap, you don't have to employ people to check on these mouse traps every 2 weeks, but you only have to send somebody when actually the mouse trap has gone off. So So who are we? We have built an IoT ecosystem of developers. That's what we do with the Things Network. And there's an open source initiative where we help people to build their first use case. And with the Things Industries, we help with all kinds of tools to scale it and to scale across a lot of different locations and sites. We have operate now around 40,000 gateways across the world. I help now almost 160,000 developers, and we have 1 million registered devices across these 40,000 gateways. And we route around now 800 messages per second, and I think we're now nearing 20 billion messages per year that we route. And yeah, that hockey stick is also, according to these analysts, going in the right direction. We're doing all kinds of conferences where we support these developers that build these use cases and build these companies on top of these use cases. And again, we're doing a large conference at the end of January in Amsterdam with a in-person and virtual event. So you're all invited. But yeah, that just wraps it up a bit. LoRaWAN is becoming a mature technology with a mature device maker ecosystem, and yeah, I hope I could inspire you a bit by all the business cases and business that's being built on top of this technology. So I want to thank you very much, and I think now it's Thomas. That's his turn.
Yes. And today I want to talk to you about Bluetooth technology and the smart home, and more especially about making the smart home easy. Before I dive in, can I encourage everybody to submit your questions in the chat so we can have a nice Q&A afterwards. So, making the smart home easy using Bluetooth. What is Bluetooth? It's technology. It's around for quite a long time, and it's managed by the Bluetooth Special Interest Group. They control the specification, qualification, test tools, the interoperability, and they control and manage the brand. So at this point, there's two variants of Bluetooth. There's Bluetooth Classic with the 2.1 spec, still used a lot in audio, and Bluetooth Low Energy, which was introduced with Bluetooth 4.0 in 2010. Currently, we're at Bluetooth 5.3, which was released just this summer. And very important, Bluetooth works in the 2.4 gigahertz ISM band, which is royalty-free. Bluetooth has has identified four major big use cases. It's Bluetooth audio, so that your wireless speakers, wireless headsets, true wireless earbuds, data, fitness trackers, and your peripherals, wireless mouses and keyboards. Location, so tags to find your stuff back, but also indoor positioning and beacons. And also access control, for example, the key fob of your car can be operated over Bluetooth. And then the last one, which is more interesting for this talk, is networks. So sense and control in industry, but Bluetooth mesh for the smart home. Now, Bluetooth mesh is a decentralized network, so there is no infrastructure needed. It's very easy for users to set up because you just add a device to your network and it's automatically part of the network. There's no configuration of routers and such things. Just adding your device to the network. And for developers, it's very easy because Bluetooth offers you a solution from the PHY up to the application layers. So there's just one source you need, and it's got you covered. But there's one new use case actually, and that's using Bluetooth as a building block in other standards. Both the Zigbee standard with Zigbee Direct and the Matter standard have adopted Bluetooth as part of the specification. Zigbee was originally a also full stack solution running on a 802.15.4 radio, and now has included Bluetooth for an easier and very secure commissioning. It's just taking out your smartphone and pairing it or connecting it to your device you want to add to your Zigbee network. It's a very easy and very visual flow for users. Matter has done the same thing. It has taken the smartphone and Bluetooth to add a new Matter device to your network. And besides that, it's not only the commissioning that can be done over Bluetooth, it's also the control of your network. You can control your Zigbee light, for example, over Bluetooth, or you can connect a smart speaker over Bluetooth to your Zigbee or Matter network and control it via voice commands. It's really, the smart home is really becoming a place where you mix and match transport protocols. So you can use Bluetooth for your one hop to the network, and in Matter you've got your Wi-Fi for your very high throughput applications, and you've got Thread also running on 1802.15.4 for your low power applications, for your battery operated devices. So each device and each use case has its ideal transport mode, and it's all, and for the user, they don't see all this different technologies behind it. They just see one unified experience. Now, if you want to make it easier for the developer, then you have to have this 15.4 and this Bluetooth Low Energy on a single chip. You have to run multiple protocols on this chip, and that means you have to do the processing of those protocols in a smart way. With Corvo, we offer you dynamic multi-protocol. So on the transmit side, you have to do automatic scheduling. So the developer doesn't have to care about scheduling Bluetooth connection events or Zigbee traffic. We at Corvo, we do that for you, and it's done smartly so that all traffic can be sent at the appropriate time. But even more importantly, it's the receive side. Common solutions for receiving two protocols are time slicing. So you listen a bit for BLE packets, then you listen for Zigbee packets. But when you're listening for BLE packets, you can't receive Zigbee packets and vice versa. This means that packets will get lost and you have higher latency in your network. With Corvo's unique concurrent connect technology, we can listen for BLE and Zigbee and Thread packets all at the same time. That means virtually no lost packets and lower latency and a much more robust support for the multi-protocol use cases. And it's especially this last concurrent connect technology we want to demo for you today. Let me quickly switch to a video of this demo. Yes.
In this video, we'll perform a live demonstration showing how Corvo's Concurrent Connect technology for IoT devices works seamlessly across multiple ecosystems. For our demonstration, we will use the Corvo QPG6100 and its development kit. To observe what's happening, we've connected the development kit to two LED light strips. The red light indicates communication over Zigbee, while the blue light indicates communication over Bluetooth mesh. Both lights are controlled by a single QPG6100. We control the red light using voice commands via Zigbee with an Amazon Echo. At the same time, we control the blue light using Bluetooth mesh with another QPG6100 development board, which functions as a Bluetooth mesh light switch. Amazon Echo and the light switch both represent separate ecosystems in a multi-standard home environment. Keep in mind, both the Zigbee and Bluetooth mesh work asynchronously. This means QPG6100 does not know when its radio needs to receive a Zigbee or Bluetooth mesh packet. Therefore, it will use Concurrent Connect technology to continuously listen for incoming packets on both standards. Notice the red light reacting to our voice commands.
Alexa, turn light on.
Okay.
Alexa, turn light off.
Okay. Now, notice the blue light turn on and turn off when the switch is pressed. Next, when we control the lighting application simultaneously via Zigbee and Bluetooth mesh, we can see both red and blue lights continue to act instantaneously to our command.
Alexa, turn light on. Okay. Alexa, turn light on.
Even when toggling both lights as quickly as possible, there is no visible latency.
Okay. Alexa, turn light off. Okay. Alexa, turn light on. Okay. Alexa, turn light off.
This shows how Concurrent Connect support works to listen and receive both Zigbee and Bluetooth mesh packets virtually without dropped communications or delay. For more tools, technical blogs, and ebooks, visit Qorvo's Design Hub. We're your partner for the toughest design challenges.
So this was the demonstration of Qorvo's Concurrent Connect, which brings us to the conclusion, basically. If you want to have a smart home, the best solution is to mix and match technologies, so you can have the best of all the worlds. And to do this, you have to do this in such a way that consumers don't notice all this technical things happening in the background, and at the same time you have to do this in a way that developers can work with it easily, and that's what we will help you do at Qorvo. Back to you, Max.
Well, thank you, Thomas. Also thanks to Vinka, Omer, and Samuela. So now it's time for our Q&A session. And I do encourage anyone in the audience who's still got questions, this will be a really good time to send them in while we still have time. So one of the first questions is, what are the big trends in Bluetooth, Wi-Fi, LTM, and NB-IoT, and also LoRaWAN? And I think maybe we'll get all of the presenters to answer this one. Samuela, since you were the first speaker, let's start with you.
Yeah, I can take this one. Thanks, Max. So I think in general, I think it's a great time for cellular connectivity, really, in general. Several standards, 5G around the corner, there are multiple threats. What is really important, I think, is that the cellular industry recognized there are multiple connectivity use cases, multiple ways of intending connectivity, and IoT and M2M machine-to-machine markets are simply diverse from the traditional mobile phone markets. So the trends here are clear. There was a clear need for, let's say, a set of new standards that are more suited for the needs of IoT. Mobility, low cost, low data rate, power efficiency, all combined with the key advantage of cellular, and that is ubiquitous connectivity. Wherever you have a base station, you have connectivity. So this is the big trend. And in addition to that, I can mention security. Security is another big thing. With millions of devices being connected with the network, you really want to have a solid solution in terms of security, and maybe you want to combine this with an efficient way of onboarding your units on cloud IoT systems that helps you scale your business. So these are the key trends.
Okay, same question to Omar. What are the big trends in all these wireless standards?
Thank you, Max. I will take the Wi-Fi part here. So in Wi-Fi, we have two major trends. One is the emergence of Wi-Fi 6, and the second is the adoption of IoT applications for Wi-Fi. So Wi-Fi now, what we see in the industry is that a lot of new kind of devices that traditionally were not using Wi-Fi, such as smart door locks, thermostats, smoke alarms, doorbells, etc. Those devices, they are adopting IoT. And what I see in next, let's say, 5 to 7 years is that in smart home, at least Wi-Fi devices, embedded Wi-Fi devices, they will become mainstream.
Okay, Vinka.
Yeah, so specifically what the kind of trend you see in LoRaWAN is the rise of private networks and more enterprise networks. So where you mostly we see customers being successful in LoRaWAN is, for instance, in large retail chains that we have, but also restaurants that do, for instance, food compliancy, ports, and that kind of thing. And what the interesting bit you see there as well is we're helping customers not only build these networks, but also build the solutions. But that also we see a network effect of different users in the LoRaWAN ecosystem that use each other's networks. So these networks are interoperable and can connect together. And that also means that, for instance, if you already have a network in for instance, a fast food restaurant, then it's really easy to, with the ecosystem, provide way more solutions inside of that restaurant. So that's I think the main trend we see in LoRaWAN.
Okay, and finally, Thomas.
In Bluetooth, we see two big things that are new. The one is Bluetooth low energy audio. So traditionally, audio was done over Bluetooth Classic. With the 5.2 specification, Bluetooth low energy audio was introduced, allowing you to have multi-stream and audio broadcast over Bluetooth low energy. And this will enable, for example, true wireless earbuds in a more efficient way than they're done today. And there is also a very big use case in hearing aids, a market that's now also served by Bluetooth, but with the battery constraints, will be well served by Bluetooth low energy audio. The second main thing is that Bluetooth's now adopted by other standards. Bluetooth is everywhere nowadays, it's in every smartphone, and by other standards adopting it, they want to use the strength of Bluetooth, the Bluetooth connection, and the fact that it's everywhere to make the user experience of their own smart home solutions better and safer, allowing their own standards to shine in where they're strong, for example, the mesh part, and then using Bluetooth for the things where Bluetooth is very strong, namely the connection to the network. And that would be it.
Okay. So we've got a question here. With the introduction of 5G, do you see any impact on Wi-Fi technologies?
I can take this question. Wi-Fi primarily is being used in smart homes, and 5G, where we see it can work as a complementary technology, but we don't see any trends where Wi-Fi 6 is being replaced by 5G or vice versa. Wi-Fi 6 itself and Wi-Fi 5 also in smart home, the adoption, the growth, it is still happening. And the way I see, let's say, down the road, I don't see one replacing other or one taking a role of another. Rather, they will be complementary technologies.
Okay. And another question here. What about the IORA helium technologies? Oh, sorry, LoRa helium technologies or LoRa helium network?
Yeah, shall I take that question?
Yeah, please.
Yeah, so on the LoRa side, so you have the beauty of LoRaWAN is that you have all these different operators. So so you have nationwide operators that can build networks. Then you have private companies that can build a network, and then you have community networks. So there's a lot of diversity in network building, and through the standards that can be interoperable. And it means that you see the emergence of all kinds of different network builders across the ecosystem, which is super interesting.
Okay, good. Another one. Will current 4G devices be usable with 5G?
Yeah, that's probably for me, Max. So, well, it depends. It depends. There are multiple implementations of LTE and multiple implementations of 5G. So LTE will be functional as a whole thing, depend on certain 5G rollout plans, not in all of them. What is guaranteed is the new technologies we spoke about today, so like LTM and narrowband IoT, they will be constantly, let's say, supported all across the industry once 5G is rolled out. So for them, we can guarantee. For the others, it really depends on the standard and depends on the local deployment that may vary quite a lot.
Okay. We've got one, I think, that's targeted specifically at Thomas. What's Qorvo's overall vision for the smart home in the future?
So Qorvo's vision is really entered on this this mix and match of different technologies. What we see for the smart home, and that's already happening nowadays, is you will have a backbone of a Wi-Fi mesh where every room will have a Wi-Fi router. So there's coverage in your house everywhere. And these routers will also double as Bluetooth access points for your network, where you can connect to with your phone. And there will also be a low power mesh, for example, Thread or Zigbee, which are connected to these Wi-Fi routers, which then will cover all your sensors and low power devices. But in the end, for a user, there will be just one big network of devices. But we call it one pod per room. So there is one very capable device, at least one of these in every room, and all the smaller devices can end to that one for the high-speed connect or for the high-speed uplink. Now, for example, the internet.
Yeah, I think it's going for the end user. I know for myself, I'm supposed to be technical, but trying to get things working sometimes can bring you to your knees in this sort of area. So for the end user to have something that's just totally transparent and all the networks working together will be fantastic. Which actually brings us to a question: what does the future look like for all of these connectivity protocols?
I can probably start off saying in the case of cellular, it's pretty easy to say it's 5G, but be aware 5G will not exist in a single form. There are multiple flavors of 5G. Let's say 5G is already here today on the mobile phone industry. It's already started, but it's not there yet on other fields or segments or market verticals. Take, for example, IoT in general, we are not there yet. So we are close to it with LTM and narrowband IoT, but it will take still a bit of time to reach 5G as a whole, as a new thing. So the trend is pretty clear in the case of cellular. It's 5G with multiple flavors. Then it depends a bit on your use case and type of applications to select one or the other flavor of 5G. What is important is to pick probably solution or a product that helps you scale or change maybe or upgrade firmware in order to get to scale and upgrade and then be compatible with the new standards while they are rolled out.
Okay. Another one, what would be the better approach, either to use a self-developed cloud-based IoT platform or to use another third-party platform like Google Cloud, for example?
Yeah, maybe I can take that. It's because you're seeing this being used in the enterprise world a lot. What our experience is that the best IoT application platform is your ERP. And what you want is that either through your cellular operator or through your LoRaWAN network server provider, you want to have a proper device management, and then maybe use some microservices and like IoT kind of services from your cloud provider, and then it needs to like be injected into your business processes. So this is from an enterprise point of view. And we advise customers always like to reduce the scope and don't directly fall for like this all you can do IoT platform, but really cherry pick like how does this data point affect my business process so it increases 200, 300 times in efficiency, and just approaches as an IT architect, but not just go acquire an IoT platform because you need IoT. Use technology to solve a problem, not go. That would be my advice. Yeah, that's happening a lot actually.
So very quick, we're running out of time. So quick tips.
Yes, from my side, I would say so Wi-Fi is a complicated protocol. So make sure that the platform that you use, the tools, SDKs, they're well developed, and it allows you to abstract a lot of complexities of the Wi-Fi protocol that you have. So choosing the right SoC with the right tools is the key here for new developers.
Okay.
Yeah, I can keep it very short. Start small. Like really don't overcomplicate things. IoT is extremely hard. Your chances of failing are around 80%. Your chances of success around 20%. So don't reduce the scope as much as you can. Keep it small, start experimenting, and reduce the risk.
That's a good one.
I think I agree there. I think it starts with contacting your favorite silicon supplier. Get an SDK, get their great sample applications, which will get you a long way. For quite a lot of IoT solutions, there are also open source stacks available which you can try out, which is also a great point to start. For example, Matter only has an open source stack available, which guarantees you also interoperability, which is also very great.
Yeah, I agree with you, Thomas. I would really just start with some application boards. There are many in the industry, in the market. From there, you can start developing directly the code. You can start really simple with those things.
I think that's really good advice, starting small and building up. I usually go the other way and crash and burn terribly. Okay, so thanks so much for the audience for their questions and to the panel members for their insights. For those of you who posted questions that weren't answered, we will be forwarding any remaining questions to the members of the panel so they can follow up with you directly later. As a reminder, this recording will be available for on-demand viewing starting tomorrow, when it will be found on IoT Central at iotcentral.io. And this brings today's webinar to a close. I'd like to thank everyone for attending and for your thoughtful questions. A special thanks once again to ARM for their sponsorship. And of course, special thanks to our speakers, Omer, Vinka, Samuela, and Thomas, for their insightful presentations. Once again, this is Clive Maxfield, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on the next IoT Central webinar. And until then, from all of us here at IoT Central, we hope you have a wonderful rest of the day.